Now it's my time to briefly share uh, the work that we would like to bring in. So let me just get the presentation in order. So thank you all for being here. And one of the causes for being here is this book, Regenerative Ecosystems in the Anthropocene. To begin with, it was possible because of the Secretary General, Right Honorable Patricia Scotland Casey. In fact, our deepest gratitude to you, ma'am, for creating this platform to share collectively and learn, and what you already expected to act for the future 2.4 billion people of the Commonwealth, not only this, but the whole globe, the planet. So there we are with the Commonwealth Symposium on Regenerative Ecosystems, the focus of which is not just ideas, but from ideas to actions. As we go along, we must remember the subtitle of this book, which is a very important aspect of how we could possibly achieve it. A transdisciplinary ecosystemic framework for regenerativeness. More in the book, but this point not to be missed out. I also, at the same point, would like to thank some of the world's best peace educators. And of course, Betty Reardon has done, she's a champion of peace education. And she has written the foreword for this book. It's a beautiful piece for you to look at, and that would give a sense of what the world thinks and the peace researchers thinks about it. Hans Gunther Broch was the series editor of the Anthropocene series. He picked up this book. He's published the previous one, but this is he picked up this for his series within the Anthropocene series. And of course, the book has 24 chapters. That means there are many authors to this book. And I want to acknowledge and thank all the 35 authors who contributed to this book. And that's how the book is out here. So with this note, let me also tell what we are going to do today. There are 6 of the authors who are going to present very briefly the 3 aspects which I hope and we hope that will be helpful for all participating today, and of course, taking it forward to action. We would talk about the basic idea or the science behind the idea of the particular work of each of these 6 authors. This is just a representative authors. There are many more chapters in the book and authors who have wonderful work in the book. So one is, of course, to look at the idea or the science behind that idea. And of course, most important is to look at the actions and the evidences. And these actions and evidences could best be understood through processes. That is how to make it happen. It's not about just the idea, but how did they make it happen? This should take a lot of time to present. That's why it is just a curtain raiser to the 2025 December conference, wherein we would discuss in greater detail. But the book itself has some ideas and the processes already laid down. So they would focus on that. And the third, of course, is what is the possible policy action? So these are the 3 aspects that each would focus. There are these the 6 authors starting from the first one, or if we get from Pavel, he would be talking about regenerative learning. Supriya Nayak would be talking about system science in healthcare. Professor Father S. Ignacimoto would talk about the importance of diversity, biodiversity and forest regeneration. And Dr. Ajit Patnaik would talk about restoring wetlands by simple controlling the salinity of the lake. And of course, Professor George Zell will talk about the policy and governance, particularly focusing on the challenges of the built-in environment that we are in, which is probably are the obstacles for moving us into regenerativeness. So, of course, I will leave the details to each of these authors to speak about, but they would talk about the specific processes very briefly and the policy action. So within each has around 15 minutes, and I hope we would do a good job of giving you an introduction to these ideas and how it takes into action. So I also welcome you before I start off. This is just the beginning, but I welcome you to the 4th International Conference on Regenerative Ecosystems. That's in December 2025. And the details, of course, we'll share with you subsequently, but we'll have a more 3-day deliberations on these issues and practices. And this time, we are also inviting biologists. We are inviting physicists and chemists to get into and tell us how the science at the subatomic level and at the cosmological level work, and not just at the ecosystem level. So we would have much more to offer in the conference that is coming in December 2025. So coming to the topic that I have, I would very briefly share this idea of the science of regenerativeness, which is primarily nothing but the all-interacting evolving system science, and take you down there very briefly. So this is the point that we talked about and the crisis that we are encountering. And let's see if the climate crisis, or primarily the ecological crisis in the Anthropocene, can it be handled by this science? That's where I would demonstrate some experimental evidence to show how it really works. So there are these 3 aspects that we already know. And this together, today, governments across the world is spending about $1 trillion as subsidies to manage these 3 aspects of air, water, and soil. There is rising temperature, and there is pollution in all the 3. And there is shortage of water, degradation of soil, and pollution of air. So, and the rising temperature of the air. So these are all happening. And how can this regenerative science help in resolving this? If it can resolve this, it can resolve the other SDGs pretty well. And the data is there, the World Bank data, which shows, and currently I saw it was $1.24 trillion. It's rising at the rate of 23 to 24%, the subsidies from across the globe. So the question is how to resolve this. And this is the condition. I'll just show you some images to get you a sense of how it really transforms. This was the kind of a situation of the actual plot in one of the remote tribal districts in Orissa in 2018. And this, from here, we built this. And this was possible even when there was drought in this area was declared drought in 2021, and it had only received half the rainfall, and we got water filled in the well that was constructed in that plot. This is another, the actual work started in 2016. This was the original condition of a piece of land here in Bhubaneswar. The land, this is of the image of May 16, 2016. And the organic carbon of this land was 0.33. And within 6 months, this got transformed to this. So that's possible. Regenerativeness is not a theory. It is possible. And of course, in the second year cycle, you can see that there is a lot of process that has to be done. It's a very knowledge intensive aspect, but it can be done. Farmers are doing it. But this is where the image of the second year. This is the image of the third year. You can see the transformation that's taking place on the same piece of land. And this is within 3 years, we had planted trees and they grew to this height. This is within 3 years. And this is the recent photo. You can see here at 40 degrees centigrade, the very soft plants are doing so well. There is no pest attack. You can see the soil color. The organic carbon of the soil will be far greater than where we began. I'll show you some of the data subsequently. But this is the current situation of this farm that we saw in 2016. So let me just give you some, very quickly, in a minute or so, some of the produce from this regenerative agricultural practicing farm. So what was the impact on climate change? We can look at some of the figures to appreciate that. This was the condition of water. The water rainfall that got absorbed in the soil rose from 40% in the very first year to 100% by third year. And we can see the data, the rise in water column height of the well in the farm. In 2016, it was 25 feet. 17, it became 30 feet. 18, this is the peak of summer. We have measured this at the peak of summer. In 2018, it became 32. 2019, it became 35, 33. So and we were consuming almost 2.5 lakh liters to 3 lakh liters of water every year. And even though we're using that much of water, the height of the water in the well was steadily increasing over the years. And you can see even now we have very high levels of water. You can get it at 7 feet or 8 feet from the ground. On the soil health, you can see here organic carbon steadily rising despite intensive cropping throughout the year. The pH took some time to balance, but you can see that it is almost becoming neutral by 2019, and it has substantially improved. I showed you the image of the current. The micronutrients, it went from deficiency to sufficiency. What about temperature? Temperature of the farm, which is the average temperature of Bhubaneswar, is around 35 degrees centigrade, has steadily gone down in the farm. It went down by 2.5 degrees centigrade in the first year, by 1 year. And then it went down to another 4 degrees or so by second year, and 5 degrees down by third year. So this is where the effect that we can see on the farm. And these were all recorded as it was an experimental exercise. So what's the science behind this? The science behind this is very simple. It is extremely simple. The science is this, that if you want water, you take care of microorganisms below the land surface. Take care of the microorganisms below the land surface. The process is very detailed. That's there in the book. One can see that. If you want subsequently yield, you want farming to be regenerative, you take care of life above the soil. That is the butterflies and bees and other flies that are there just above the soil. So if you balance these two, life, the weakest life below the soil and weakest life above the soil, you would achieve the rest of it. That's what we did in this farm, and it hints to some of the very important aspect of what Honorable Patricia mentioned about our orientation, our approach, our method of looking at the problem. And that's where the science comes in. It primarily rests on 3 axioms of interconnectedness, interdependence, and interactions. This is what happens in the nature. Everything is interconnected with everything. Everything is interdependent with everything. Everything interacts with everything, even if we like or not like. It occurs at the subatomic level, at the cosmic level, at the ecosystem level, at human scale level. So it happens all the time. So only thing that that we have as human beings is the intentionality. This intentionality is about 2 opposites. There are, of course, the details not for today. We can discuss that some other time or during the conference. But intentionality is whether it's a self-centered intentionality or weakest other-centered intentionality. Weakest other-centered intentionality, the farm produce the output that we saw. So it, of course, requires the coherence and balance in philosophy of science, in particularly bringing in the axiology, to be able to derive an axiology which is in line with the axioms that we have laid down here. And of course, a balance in our thinking, doing, and living. That's where the coordination among human beings, the partnerships among different experts, disciplines is required to be able to achieve this. Otherwise, knowledge is very easy. The science is very simple. So how to operationalize this? So the first part is, this is an important point to note, especially for the UN and Commonwealth and the standard scholarship in Sustainable Development Goals. This is how sustainability is defined. It's looked as trade-off between social, economic, and environment. This AISS framework or regenerative science needs to review this and look at it very differently. They are not competing with each other. They're embedded into each other. These are interconnected. They are embedded, and they are complementary, therefore, not competing with each other. So the standard framework, there is an issue with the standard framework. And of course, this also is easy to understand, but we can have greater discussion later during the conference, that they are not competing with each other. They are complementing each other. They're embedded, deeply embedded into each other. And there is a prioritization of their embedment. So if you take care of the ecology first, the climate issues first, or ecological imbalance first, then the social aspects improve, the political structure, governance has to be around that, it has to be decentralized, and economic outputs are just a manifestation of balancing the first three. So if you take a simple example, if you take, let's say, the country India, you just have to take a district or a state and take a district and look at a gram panchayat or a ward, and the work would begin from there as the smallest unit where you can actually achieve SDGs simultaneously and holistically. So this is the framework that is proposed, that if you take the regenerative ecosystem as a gram panchayat or a ward or commune or GN, there are different names, nomenclatures for different countries across the world for the lowest level of governance, which is actually the basic unit of an ecosystem, a micro watershed or a couple of micro watersheds together make a gram panchayat the lowest unit of governance. So these are the four fundamental ecosystem services that has to be fixed in place first. And then the rest four are primarily economic and primary, whether it's agriculture or services or processing, and organization which manages all this are all economic activities. We have taken the example of primary sector agriculture because the evidence is very easy to observe. The changes can be very easily observed when you make these small micro changes. But it's applicable across, and this is where the mapping has been done. If you take the SDG goals and map it against these 8 dimensions that we shared, it's almost impacting all the SDG goals. And here again, there's a detailed work which we can discuss later. And this is the broad output that one can see, that if you intervene in a holistic, systemic, and simultaneous manner with a coordinated effort, this is where the accounting has to take into account the indicators that are required for this kind of coordination. And the results, you're seeing this is the figure, the current figure that for the Indian context in the rural ecosystem, is the average income is around 10,000 rupees per household per month. And we can raise it to 5 times within 5 years, within 5 to 6 years. And it can go up to 10 times in about 7 to 8 years because of the ecosystem services effect and the coordination effects. Because we operate independently, it is not becoming possible for farmers in the rural ecosystems to make their ends meet. So with that, I would thank you for your patience listening.